Good morning to all. Today we are discussing about digital to analog converters. A digital to analog converters converts a digital signal to an analog signal. That circuit we are called as digital to analog converter circuit. Okay. For example, here we are consider the digital to analog converter circuit. Okay, and here we are giving the input signal is the digital input or digital bit word, that is 101101. So this digital bit word is given to input of this digital to analog converter, and this converter can be converting this given digital information to an analog information form. Okay, and here we are collect the output signal in the analog form. Okay, and this output signal may be available in voltage form or current form. Clear? And now here our doubt is how this digital to analog converter circuit can be converting the given input to digital signal to an analog signal. Okay, and here we are discussing the internal circuit diagram of the digital to analog converter circuit. Okay, for example, here we are consider this internal circuit diagram of this digital to analog converter, and here we are consider the digital bit word is 3 bits. Okay, so here that is 101. Okay, and with respect to this circuit, here we are converting the digital signal to an analog signal. Basically, this digital to analog converter can be adding the given input voltage to under the control of the binary information. It means that in this circuit here we are using the adder circuit, and this adder can be adding the this given input voltages. Okay, and this circuit can be adding this given input voltages under the control of these binary signals. Okay, for example, here we are assuming the digital input is 000. It means that this is we are assuming the most significant bit MSB, and this is the LSB, and here we can assume this is the B1, this is B2, and this is we can assuming B3. Okay, with respect to this circuit, here we are apply the binary bit is 0, and this B2 bit also 0, and this B3 bit also 0. At that time, this can be acting as a switches. With respect to this binary information, these switches can be acting as a closed switch or open switch. Okay, for example, this switch will be open when we can apply the input is binary 0, and this switch can be acting as a closed switch when we can apply the given input is the binary 1. Okay, for example, here we are giving the 3 bits information is 000. At that time, these switches can be acting as a open switch. So here we are not connecting any voltage to the input of this adder circuit, and here we will not getting any output. Therefore, here the analog output signal is the 0. Clear? And for example, here we are giving the another input signal is 001. At that time, here the B1 bit is 0, and B2 bit is 0, and B3 bit is 1. So here with respect to these two given binary bits, these two switches can be acting as a open switch, and coming to this B3 bit, this switch can be acting as a closed switch. If the switch will be closed, this 1 voltage signal is given to input of this adder. With respect to these two given binary inputs, so here we can get the output is 0 0. So this adder can be adding the 3 voltages, then we will get output is 1. So here we will get the analog output signal is 1. Okay, and similarly here we are giving the another digital bit word is 010. At that time, this B1 bit is 0, and B2 bit is 1, and this B3 bit is 0. At that time, with respect to this B1 bit, this switch will be open, so this 4 volt signal is not connected to input of this adder, and this B3 bit also 0, therefore this switch also be acting as a open switch, and this 1 volt signal is not connected to input of this adder. But coming to this B2 bit, here we are giving the binary information is 1. With respect to this information, this switch will be closed. So if the switch will be closed, this 2 volt signal is given to input of this adder. So here this adder can be adding these three signals, then we'll get the output equal to analog signal output, that is 2 volts. Okay, similarly here we can apply the another input signal is 0 1 1. Clear? At that time here the B1 bit is 0 and B2 bit is 1 and B3 bit also 1. With respect to this B1 bit, this switch can be acting as a open switch, therefore this input signal is not given to input of this adder. And coming to this B2 bit and B3 bit, here these two switches can be acting as a closure switch, therefore these two input voltages are applied to input of this adder, and this adder can be adding these two given input voltage, then we'll get the output equal to 3 volts. Okay, so in this way we will get the digital bit is input of this digital to analog converter, and this converter can be providing output is analog form. Okay, and with respect to these conversions, we can deriving the one mathematical expression of this digital to analog converter, that is the output of this digital to analog converter circuit V naught equal to K into, here we can mentioning the VFS means full scale voltage. This full scale voltage we are also called as a reference voltage. Means here we are assuming the input voltage are 4 volts and 2 volts and 1 volts. Okay, these voltages we can obtain from the reference voltage. So here that is we can mentioning here, that is the reference voltage or full scale voltage of, here we are mentioning the most significant bit, that is B1 into 2 power minus 1 plus B2 into 2 power minus 2 plus B3 into 2 power minus 3 and so on Bn into 2 power minus n. So here with respect to this mathematical expression, we are converting the digital signal to analog signal. But here our doubt is why we are mentioning this 2 power minus 1, 2 power minus 2 and 2 power minus 3 and so on 2 power minus n. So these values can be indicating the weighted resistors in this given circuit. Here I am not mentioning the any resistor values. Okay, so in the practical circuit definitely we are considering the weighted resistors. So with respect to that weighted resistors, we will get the overall output voltage expression of this digital to analog converter is V naught equal to K into VFS of B1 2 power minus 1 plus B2 2 power minus 2 plus B3 2 power minus 3 plus Bn 2 power of minus n. Okay, so in this way we are converting the signal from digital format to analog format, and here this K is the ideal factor. Okay, always we are mentioning this value is 1. Okay, and now we are discussing about schematic symbol representation of the digital to analog converter. This is the schematic symbol representation of the digital to analog converter, and here we are giving the input signal is the digital bit word. For example, here we are assuming the digital bit word or the digital input signal is 1011. Okay, so this signal is given to input of this converter, and this converter can be converting the signal from the digital form to analog form. Okay, but here in this the digital bit word, this is we are consider the MSB bit, and this is we are consider the LSB bit. So here the MSB bit means the most significant bit, and this is the topmost bit in the given digital bit word, and this is the least significant bit, and this is the lower bit in the given digital bit word. So here we are giving the input signal in this following format. So here we are mentioning the most significant bit, and here we are mentioning the least significant bit, and with respect to these input bits we are converting the signal from the digital form to analog form. Okay, and we know that the output voltage expression of this digital to analog converter is V naught equal to K into VFS of B1 into 2 power minus 1 plus B2 into 2 power minus 2 plus B3 into 2 power minus 3 and so on Bn into 2 power minus n. And we know that here this 2 power minus 1, 2 power minus 2 and 2 power minus 3 is indicating the weighted resistors in the given circuit. Okay, and this is the way we can consider the reference voltage. And here why we are consider this B1 value, B2 and B3 values, it means that with respect to this binary bit value only we will get the corresponding output. It means that the switch is controlled by the this given binary signal. So here we are mentioning this binary bit into this corresponding resistor value. So in this way, we will get the output voltage expression of this digital to analog converter. Okay, and now we are discussing about Dac response. It means that here we are consider the digital to analog converter circuit, and here we are giving the input signal is the binary bit word, and here we are collecting the output signal is the analog signal. Okay, and we know that the output voltage expression of this digital to analog converter is V0 equal to K into V reference voltage or V full scale voltage into B1 into 2 power minus 1 plus B2 into 2 power minus 2 plus B3 into 2 power minus 3 and so on, Bn into 2 power of minus n. Okay, and here we want to discussing the Dac response. It means that with respect to this input and output, we are draw the waveform. That response we are called as Dac response. Okay, so here we are consider the digital bit word is 3 bits. Okay, so here we are consider the digital signal is the input, and here we will get the analog signal is the output. Okay, and here we are giving the digital bit is the 000. Okay, with respect to this given digital bit, we will get the output is 0. Okay, and similarly here we are consider the another input bit is a 001. At that time, here we can assuming the reference voltage is 8 volts. Okay, and this values we can substituting here, then we will get the output voltage V0 equal to here K equal to 1, and Vf is also we can assuming 8 volts, that is 8 into what is the B1 value here 0 and B2 value also 0, so this values become a 0, and what is the B3 value here, that is 1 into 2 power minus 3. We can simplifying this, we can get the 1 by 8 equal to 1 volt. So here we are giving the 001 bit is input of this digital to analog converter, we can get the output equal to 1. Okay, similarly we are giving the another digital bit what is 010, and we will get the output is 2 volts. How to get the 2 volts means if these digital bit what is substituting in this above equation, at the time this B1 bit is 0 and this B3 bit also 0, so here you will not getting any values, and only here the B2 bit is 1. So 1 into 2 power minus 2 will get 1 by 4, and 1 by 4 into 8 will get them 2. Therefore output voltage is equal to 2 volts. You will get the output voltage is 2 volts. Similarly here we are consider the another digital bit input combination is 011. At that time we will get the output voltage equal to 8 into here B1 bit equal to 0, then we will get the output is 0 plus with respect to this B2 bit, here we will get the value is 1 by 4 plus similar with respect to this B3 bit, we will get the value is 1 by 8. Okay, now we can simplifying this numerical values, then we will get output equal to 3 volts. Okay, 3 volts. Therefore here we can get the output is 3 volts. Similarly here we are consider the another digital bit input is 100. At that time only here we will get the output equal to 8 of with respect to this B1 bit, this value is 1 by 2 and other two values are 0, then we will get the output value is 4 volts. Okay, here we will get the output is 4 volts. Similarly we are consider the another possible combination of this given digital input bit is 101 and 110, and the next one is the 111. Okay, so here we are giving the input is 101, we'll get the output equal to 5 volts, and we can give the input is 110, we'll get the output equal to 6 volts, and we can give the input is 111, we'll get output equal to 7 volts. Okay, and now with respect to this given digital input and output, we are draw the waveform. That response we are called as digital to analog converter response. Okay, so here we are consider the digital input, and here we are consider the analog output. Okay, first of all here we are giving the digital input is 000. If we are giving the digital input 000, what is the output here? 0. And similarly here we are giving the another digital bit input is 001. If you are giving the digital input is 001, we will get output equal to 1 volt. So here we are assuming this is the 1 volt. Okay, and similarly we are giving the another digital input bit is 010, that is 010, output is 2 volts. So here we are assuming this is the 2 volts. Okay, and we can give the another digital input bit is a 0 1 1, output is 3 volts, and another digital input is 1 0 0, output is 4 volts, and another digital input bit is 1 0 1, output is 5 volts, and another combination is 1 1 0, output is 6 volts, and another input combination is 1 1 1, we get output equal to 7 volts. Okay, so here with respect to this given digital inputs, we'll get output is the analog signal. But here the analog signal suddenly not move from the 0 to 1 volts. So here the analog signal can be move like a step signal. Okay, here to here the analog signal suddenly move from the 0 to 1 in a step format. Okay, similarly here we'll get the analog output signal like this format. Okay, now we can observing this DAC response. It will be look like a staircase signal. Okay, and here this is we are consider the step size. Okay, with respect to this LSB bit change, the output also be changed. Okay, so in this way we are draw the DAC response. Okay, thank you.